Tech in 5.
Dive into Python with a fun game. Learn in just 5 minutes.
Ever wondered how multi-threading can supercharge your Pygame projects? Let's dive in and find out in 5 minutes. Welcome back to our Pygame development series. Picture our Pac-Man game running on while loop. As the player controls Pac-Man through the maze, the ghosts also need to move independently. But here's the challenge. In a single while loop setup, Pac-Man's movements could potentially block or delay the ghost's actions, leading to a less responsive and interactive experience. This is where the magic of multithreading comes into play. But what exactly is multithreading, and how does it ensure that Pac-Man and the ghosts move smoothly and independently? Let's uncover the answers together. You can think of multithreading in our Pac-Man game as a team of skilled workers, each dedicated to a specific task. Imagine each ghost being handled by its own worker or thread, while the main player, our beloved Pac-Man, is controlled by you through one thread. These other threads keep each ghost moving independently. In Python, this is achieved with the threading module. Think of each thread as a separate pathway where a part of our game's actions occur. So, one thread is responsible for Pac-Man's movements, while other threads are assigned to each ghost. This setup ensures that even if one ghost is in the middle of deciding its next turn, it doesn't hold back Pac-Man or the other ghosts from continuing their own movements. The result is a more dynamic and responsive game, as various activities, like character movements, are handled simultaneously in their own threads. As we take the advantages of multi-threading in Pygame, it's important to also consider its limitations. One significant aspect in Python's threading is the global interpreter lock, commonly known as the GIL. The GIL ensures that only one thread executes Python bytecode at a time, which means in CPU-bound tasks where processing speed is crucial, multithreading might not offer a performance boost as expected. Furthermore, multithreading introduces its own set of challenges. Race conditions can occur when threads try to modify the same data simultaneously. This can lead to unpredictable results and bugs that are hard to trace. Additionally, managing shared states across multiple threads adds a layer of complexity to our game's logic. It requires careful synchronization to ensure data consistency and to prevent issues like deadlocks. While multithreading is a powerful tool in Pygame development, there are scenarios where multiprocessing becomes a more effective alternative, especially for CPU-intensive tasks. Multiprocessing involves running separate processes, as opposed to threads, each with its own Python interpreter and memory space. This approach allows true parallel execution of tasks, hence boosting performance in CPU-bound operations. Multiprocessing allocates separate memory for each process, eliminating issues like race conditions. It's a crucial distinction that can significantly impact the design and performance of your game. Opting for multithreading in our Pac-Man game, we prioritize responsive interactions over raw processing power, suiting Pygame's event-driven nature perfectly. Let's break down the code to understand how it works. First, we've modified our Pac-Man class, inheriting from Python's threading.thread. This allows Pac-Man to operate on a separate thread, independent of the main game loop. We introduced a running flag to control the thread's activity. When we start the game, we set this flag to true and kick off the thread. Inside the run method, we've created a loop that continues as long as running is true. In this loop, Pac-Man's mouth toggle and movement methods are called at specific intervals, managed by sleep method. This ensures that Pac-Man chomps and moves smoothly, without interrupting the main game's performance. Finally, when the game is about to quit, we set running to false using the stop method. This gracefully ends the thread, ensuring there are no hangs or crashes when we close our game. In our main game loop, when the game starts, we initiate the Pac-Man thread. When exiting, we ensure to stop, avoiding any potential hiccups. Now, you might be thinking about the ghosts. How do we apply threading to them as they roam freely in the game? That's an excellent observation and precisely what we'll delve into in our next video.
Stay tuned for more videos on Tech in 5.